Welcome to the Physics Master Revision Session 3B. Yes, so in 3A, we looked at this question. It was part of what we looked at. And now in session 3B, we will start from question number 20. Okay, the figure below shows an electric circuit. Okay, state Ohm's law. Now, Ohm's law is about the relationship between current and voltage, and they are always directly proportional, of course, at a constant temperature. So how do we state it? So we say at a constant temperature, the current in a conductor is proportional to the potential difference, PD. Yes, so the current in a conductor at a constant temperature is proportional to the potential difference. Now this part is very important, that is at a constant temperature. So always capture it. Okay, the next one we're being asked to write 3 factors that affect the resistance of a wire. Factors affecting the resistance of a wire. So length, good, of the wire. The next one we will have the cross-sectional area of the wire. And then what's the next one? Yeah, the temperature. We have talked about temperature in Ohm's law. Temperature. And then we can add another one. It's always the type of material. Okay, these factors affect the resistance of a wire. Part C, calculate the total resistance. We want to get the total resistance of this circuit here. Now, if you want to get the total resistance, always try and look for the smallest part of the circuit that you can simplify. Now here, where do we start from? I can't start from the 9, neither can I start from the 4, but the smallest part that we can start with is here. Yes, this one. So I'll get the total resistance here. So we have this 3 and the 6 ohm resistor in parallel. When 2 resistors are in parallel, you can directly use this formula. R is equals to the product of the resistors, 3 times 6, divided by the sum of the resistors. And this is going to give us, so you take 3 multiplied by 6, and then you divide by 3 plus 6. So you end up with 2. So here we have 2 ohms. Good. So here, these 2 will give us 2 ohms. And then from there, where do we move to next? Next, now we bring in this 4 ohm. Because the 4 ohm resistor is now in series to the 2 ohm resistor. So it's much easier to combine these two. So now I'll have this one. So because they are in series, the total resistance R is given by the sum of the 2. So I'll have 4 plus 2. This will give me 6 ohms. Okay. And then from there, from this now we have 6 ohms. From there now we have the 6 ohm resistor it is in parallel to this other 6 ohm resistor. So when the two are in parallel connection, I've said you can directly do this. You can have 6 times 6 over 6 plus 6 in order to get the total resistance. So here we end up with 3. So 3 ohms. You can use that method. Somebody else can use the long method. If you want to get the total resistance of two resistors in parallel, like in this case, I can go ahead and have 1 over R is equals to 1 over 6 plus 1 over 6. If you add these two, you end up with 1 over 3. So 1 over R is equals to 1 over 3. Therefore, R will be equal to what? The reciprocal of 1 over 3, which is 3 ohms. Yeah, you still get the same thing. Now from all this setup here, the upper part, all this, now we have, from all this now we have 3 ohms. So the 3 ohms resistor is now in a series connection to the 9 ohm. So how do we get the R total? We'll have series, we add them, 9 plus 3, and this will give me 12 ohms. So the combined resistance here is going to be 12 ohms. The combined resistance is going to be 12 ohms. Okay. Number 21, the figure below shows an electric circuit. Okay, we have the circuit. State Kirchhoff's first law. Kirchhoff's first law is about current. The sum of the currents entering a point or a junction is equals to the sum of the currents leaving the junction. So the sum of currents entering a point is equal to the sum of currents leaving the point or the junction, the point in a circuit. Of course, in all this we have some circuit. It's always summarized as the current in equals to the current out, but of course we must have a junction. We must have a junction like this point. This is called a junction. So the sum of the currents entering this junction is the same as the sum of the currents leaving. So the ones entering here is I1. I1 is coming down. I2 is also coming up. They combine here and enter this one. So it's like I1 plus I2 is equals to I3. The ones entering are I1 and I2, then the one leaving is I3. Okay, next you're being asked to calculate the currents I2 and I3. I2 and I3. Okay. So if you have a circuit like this one, look at the loops that you have and which one can you easily use to get what you want. Let's consider the lower loop. The lower loop running from EDCFE. If we choose this one, then we don't have I3 and we don't have E2. So two things are missing. It will be very difficult to get them. Remember what we want is I2 and I3. And I2 is here and I3 is here. So if we choose the lower one, we will have two things missing. Is it two things? In fact, it's three things. I3, I2, and E2. Let's look at the upper loop. The upper loop I think it's much better because only I3 is missing. Yeah, only I3 is missing. And the outer loop, the bigger one, we have two things missing. We have E2 and I2. So we'll use the loop A, B, C, F, then back to A. Yeah, this loop. This is what we'll use. Yeah, of course, we're using this with the Kirchhoff's second law. The sum of the electromotive forces, which is only one here, is equals to the sum of the potential differences in a closed circuit. So 20 is equals to the sum of the potential difference here. Remember, V is given by IR or R times I. So the voltage here will be 5 multiplied by 0.9 plus the voltage here will be, that is the voltage through the 10 ohm resistor. The voltage through the 10 ohm resistor, so here is 9, then plus the voltage through the 10 ohm resistor, which will be 10 multiplied by, or I3 we don't have, so I can just write I3. I can avoid the multiplication. Then plus the voltage through the 2 ohm resistor and the 1 ohm resistor. Now these two, they are in a series connection. I can just add them. So I can just use 3, then multiply it by I1, which is 0.9. So these two, you add them, 1 plus 2, you get 3 ohm. So 3 ohm is 1 combining this and this, and then we still have the same current, which is 0.9. So what do we have here? So I'll have 5 times 0.9, 4.5. So 20 is equals to 4.5 plus 10I3 plus 3 times 0.9. So you get 2.7 plus 2.7. Now we'll have 20 is equals to, I'll collect the like terms, so I'll add 2.7 plus 4.5, or 4.5 plus 2.7, still the same thing. Then I'll get 7.2 plus 10I3. So the 7.2 will cross to this other side. I'll have 10I3 is equals to 20 minus 7.3, and that is 12.8. So I3 will be equal to 12.8 divided by 10, and that will give me 1.28 amperes. So I3 is equals to 1.28 amperes. So we have I3. Good. Now we want to get I2. Now I2, we will use this equation. Now look at this current. The current I2, the current I3, and I1, they are related. From Kirchhoff's first law, I talked about it in the question before. How are they related? If we add I2 and I1, we're supposed to get I3. So I2 plus I1 is equals to I3. But what do we want? We now want I2. So I2 will be equal to I3 minus I1. So I2 is equals to, what is I3? I3, we have it, that is 1.28 minus I1. What is I1? 0.9. Therefore, I2 is equals to So 1.28 minus 0.9. I end up with 0.38. So 0.38 amperes. I2 is equals to 0.38 amperes.